Okay, so for our next video, we're gonna look at absolute value inequalities. And so I want to remind you what this looks like. This could be something along the lines of absolute value of x plus 3 less than 4. Okay? And so before I discuss how to do this graphically and how to do this algebraically, I want to talk a little bit about what this means as far as two different graphs being graphed on the same grid. This left section, as we know in the previous videos, if you've watched them, that's the V. That's the absolute value section. This right graph, this 4, is a linear piece. It's going to be a constant line. And we're going to compare these two pieces. So if we come back over here and look at my board, I'm trying to do a little bit of notes with you, so you may want to jot this down. But if you see that your absolute value is less than your linear, what that means graphically is that the absolute value is going to be below the line. When you graph, your absolute value is going to be below your line. Okay? Absolute value less than or equal to the linear means that you're still going to be below, but you could also be on the line. Okay, so below or on. And we're going to do some examples. So right now, just kind of take this in and think about it. Absolute value greater than linear. Well, if less than was below, greater than is going to be above. So absolute value above the line. Well, greater than or equal to is going to mean that absolute value is above or on the line. Okay? So we're going to talk about this as we do some of the examples coming up. But again, to recap, less than means your left side function is going to be below your right side function. This could be absolute value in linear. It could be quadratics and cubics. It's all whatever the problem is, left side versus right side. Absolute value less than or equal to linear means below or on. And the same thing with above on this bottom two pieces here. So let's do an example. If we look at the absolute value of x plus 3 less than 4. Again, graphically that means the absolute value will be below the linear. That's the only section that we care about. So let's look at this as a graphical picture. So I'm going to go to my calculator. I want NY1 my absolute value. So I want math, number, ABS. Inside here we have x plus 3. Okay, that's my absolute value section. My linear section was just 4. And we're just going to graph. Just going to graph this. So there's my V, there's my absolute value, there's my linear. And now with equations, all we cared about was the two intersection points. But now with inequalities, again, we've got the inequality x plus 3 less than 4. This less than means we only care where the absolute value is below the line. So I only care about this section right here. Try to make this visible for you here. This section right here is all I care about. And we want to kind of just state that as an interval, you know, from what to what. Well, if you notice, we stop right here at our intersection points. So if we can find these intersection points, and we can because we did it with equations, we could use those to actually help confine our answer for inequalities. So real quick, let's find these intersections. Second, trace, intersect. Move your cursor to the left side to find that one first. Get real close to it. Okay, hit enter on the curve, hit enter on your line, and hit enter for guess. And we're told that this is when x is -7. So I'm going to jot that down real quick. Find the other one the exact same way. Second, trace, intersection. Come over here to where that intersection point is. Mine takes a little while, so bear with me. Passed it up, so I'm going to come back here. Get real close to it. Hit enter on the absolute value. Hit enter for the line. Hit enter because we definitely want to guess here. And we find out that x is 1. Okay? So now, why is that important? So why is that important? Because we know that at -7, the line and the absolute value are equal to each other. Well, we don't care about equal to in this problem, but we know right there is where you start. So I'm going to start at -7, and then my absolute value piece continues to be below that line all the way up until it touches that line again, which is when x is 1. So we know from -7 to 1 is going to be the answer. The only question is it's going to be a parenthesis or a bracket, and this goes back to however your teacher discusses it with you. But I always talk about if it includes or doesn't include. Well, do we include on the line, or do we just care about below the line? We just care about below in this situation, so there's no inclusion, which means it's going to be a parenthesis on the -7 and the 1. Now, if we cared about on the line, then it would be a bracket on both of these pieces. And we'll do an example with that next time. Okay, so the answer to this one graphically is from -7 to 1. Let's prove that algebraically. Let's take this exact same inequality and let's do this algebraically. So we want to solve this. You've got to isolate first. There's no coefficient. There's nothing being added or subtracted, so we are isolated. So we make our two problems. X plus 3 is less than 4 is the right side, the positive side of my number line. X plus 3, and I multiply the 4 by -1 to be the left side of my number line, but remember the rule. When you multiply or divide in an inequality, you've got to flip your sign. So do not forget to flip that sign. That's probably where most of the mistakes occur in these problems algebraically. Then go back and solve these. Very short and sweet. Subtract 3 to get x is less than 1. Multiply first here. Then subtract 3 to get x is greater than -7. So these are my two solutions. But again, we care about graphing inequalities on number lines, so we can do intervals and all that good stuff with it. So let's graph these on a number line. -7 and 1. I'll change my color here. There's no equal to, so it's going to be an open point at -7, greater than points to the right. Open point at 1, less than points to the left. So these two pieces are going to be one solid piece here in the middle. So your number line graph would look like that. So your interval notation is going to be a parenthesis at -7 to 1 with parenthesis, which is exactly what you got when you graph these on the other screen. So algebraically again, graphically, exact same answers. Whichever process you prefer is the one you should use. Okay? We'll do another example in the next video, so check it out.